Hi everyone! Today is Wednesday, September 21st. So today we will talk about section 3.4, graphs of polynomial functions. And so this week you don't have quiz, but please try to finish your homework as soon as possible because our homework due date is Monday. Okay, and it's from homework 1.1 to 3.4. Okay. Uh, for the homework, do you know that you can see the homework solution? Do you know that? Okay, let me show you. Yeah, you can see the homework solution. So when you click a homework, and so let's say I click any of the homework assignments, and then you click next. So you finish your homework, and then after you finish all the problems, when you hit submit, there is option say view details. Okay, let me press all the buttons. Okay, so now after I press like question 10, I click submit assignment. Then yeah, because I didn't answer any questions. Right? That's why it gave me the warning. But if you submit your assignment, and don't quit and save. Do you see this button, view details? You click that, then you can see all the solution. Okay, so you can see your feedback and the correct response and the solution for each problem. So if you don't know how to do a problem, submit your answer. Then you can see the solution. And then when you open a second attempt, maybe on some cases, maybe Mobius will generate a new type of problem, or maybe in some cases, Mobius will give you the same type of problem, but just a number change. Yeah, yes, right. So if you don't know how to do a type of problem, submit that attempt and then open a second attempt. Mobius will remember your correct answers. Okay, so for the problems you already get it correct, you don't have to redo it. But for the problem you got wrong, you can look at the solution and understand the problem and then try again. Is that clear, everybody? Okay, yeah. So all the some problems you can see more details, right? Uh, let me see. Is there a way to save this as a PDF? Yeah, print. See everybody? My suggestions for all your homework after you finish, click the print, and then you can save as a PDF. So imagine right before your exam, what do you want to review? Your notes and your homework and the quiz and the mistakes, right? So it's good to save as a PDF. Then you can review what mistake you make, or maybe for your second attempt you want to get 10 points, right? So you can look at your first attempt PDF and see which problem you got wrong, and then you look at the notes and then understand that problem and try the new problem. Okay, everybody? Mm-hmm. All right. So this is very, very important. So yeah, I can save as a PDF. Then yeah, you can save as a PDF. For example, I can save in my download, and then I click save. Then here I save my homework. Is that clear, everybody? So you can save all your homework solution, and then you can review those before the exam. Okay. So, and some of you tell me that the homework, some homework assignments are harder than the in-class example, and that's normal because in class example we just talk about this topic when we cannot cover like all types of problems about this topic. So that's why usually we cover the more like basic type of problems, and then your homework will be maybe some of them are easier, but some problems might be more challenging. Okay, that's good. That's also the good thing about the Mobius. You can have a lot of practice, right? it also gives you solution. And if you don't understand, please feel free to come to see me, okay? Or email me, print screen your questions and ask me. And then, yeah, I will explain to you. Or maybe you can have like more exercise. You can try another one and then, yes, okay. So any questions about your homework? Good. Okay, maybe I want to like talk about this again if we have more students come here. Okay, so that's the homework. The quiz, I already graded the quiz. So the quiz, we have two problems, right? The first problem, we want to solve this absolute value inequality. Yeah, many of you get this problem right. So we add 2 on both sides and then divide it by 5. And we break the absolute value. Remember, distance small means it's inside the region minus a and a, right? X is between minus a and a. If distance is big, how big? Outside that region. So x is less than negative a or greater than a, right, everybody? So that's why here, distance smaller than or equal to 4. So when you break the absolute value, you have 6 minus 7 is between negative 4 and 4. And then both, add 7 and then divided by 6. So our answer is from 1/2 to 11/6. Okay, so that is the first problem. And we have a second problem, right? So we want to graph the functions and be sure to show the sequence of transformations with the correct order and the correct formula at each step. So first step, our parent function. Because this is something square, we know our parent function is x squared. And x squared, you want to write down the key points. The key points are 0, 0, 1, 1, and 2, 4. Right, everybody? And please label the important points. So 0, 0, 1, 1, and 2, 4, label them. And then, so remember the order of transformations? The first one we shift level right. The second one we fraction over the y-axis and possible horizontal compress, right? And then the third one we fraction over the x-axis and vertical stretch, right? And then the fourth one is shift up or down. So this is the correct order. And because we see x minus 3, so we have shift left or right. And left is plus, right is minus. Yes, everybody? Right is minus. So minus 3, shift right 3 units. So look at those key points. So 0, 0 now is shift to 3, 0. 1, 1 is shift to 4, 1, right? So this is the new graph. And next, do we have refraction over the y-axis? No, because we don't have a minus sign in front of the x. Our minus sign is in front of the whole thing, right, everybody? So we have refraction over the x-axis. Okay, the y is changing to minus y. Okay, and that's why here refraction over the x-axis, this x is the same, the y we have a minus sign in front of it. So that's why the point 3, 0 stays here, and then the 4, 1 flip to 4, negative 1, and the 5, 4 flip to 5, negative 4. Is that okay, everybody? And then vertical stretch by a factor of 4. So x value is the same. Y value multiplied by 4. That's why the 3, 0 stay the same. But the 4, negative 1, the negative 1 multiplied by 4 is negative 4. Do you see this point is now 4, negative 4? And the next number is negative 16. So it's too far away. So we don't need to draw it. Okay. Because it's outside of this picture. And then the last one, add 2. So we shift up 2 units. Okay, we shift up 2 units. this is the transformation. Any questions about the question solution? All good. Now let's look at mistakes. Okay, so here, I think, okay, what is the power? Okay, so here the mistake is this is -3. So we shift right, and then refraction. This is minus, and then vertical stretch by 4. So please tell me, is vertical stretch or horizontal compressive stretch? Because we can have horizontal compress or stretch, or vertical stretch or compress, right? So please write down is vertical. Okay. And then here, please label the numbers, okay? Just when I grade your exam, we have 33 students, right? A lot of exams that I need to grade. So please label the important points. Is that okay, everybody? Label the important points. You don't expect me to count 1, 2, 3, 4, 5, 6, 7, 8, 9, but each student, right? So please label them. And here, when you say vertical stretch, you don't say vertical stretch of 4 units, of a factor of 4. Okay, so you multiply by 4, you're not adding 4 or subtract 4. Okay, so a factor of 4. Okay. And yeah, so that's why this one is rough. This should be 2 and -2, so not -3. Okay, so label them. All right, and then here, square, miss the square. So here, when we just do the refraction, we don't have the 4 yet. And then this step, when we do the vertical stretch, we multiply by the 4. Okay, everybody? So this is square. So small mistake. And then x squared. Okay, math move again. X. Everybody move your hand. X. X squared. X cubed. Square roots. Cube roots. Yeah? And x to the value. Yeah, reciprocal. Like that. Right? Okay. So x squared like this. So the key points are those 5 key points. And then this is right. Oh, but here, vertical stretch by factor of 4, you see? If it's 1, then it should go to 4. So not 3. Okay? I think the student make multiplied by 3. It should be multiplied by 4. Okay. But you see, I give you partial credits. If you get this, so this problem has 6 points. Missing the parent function, so subtract 1. And then here, either multiply by 4 or multiply by 3 instead, so lose 0.5. But I gave you the point for these two, okay? So I give partial credits. So please write down everything, okay? You have partial credit. Even though your first step is wrong, you still earn a lot of points. Okay. And then, oh, here. Okay, be careful. If distance is small, then that means the 6x minus 3 is less than equal to 4 and greater than equal to minus 4. This is not or. This is and. It's bounded between them. So that's why subtract 0.5. Or if you want to write it into interval notation, it's bracket 1/2 comma 11 over 6 brackets. Okay, everybody? Inside is and. It's bounded between here and here. Okay? And outside is use or. Is x is less than -a or greater than a. Yes, everybody? So be careful. And then here, the students review the notes. Okay? I don't know who made this mistake, but yeah, look at the solution, review the notes, and yeah, come to see me, okay? So the step, we start with x squared, and then we shift right, yeah, so review the notes, and come to see me, okay, if you have questions. And here, oh, thank you. Forget the and, okay? That's very important. And how about here? Oh, stretch, vertical stretch by a factor of 4, okay? And right. Yes, missing the and or very important. Don't miss that. Here, that's why key points. Key points. See, bravo. Label it. Okay, make sure. Label your important points. If you can hear that, please raise your hand. Label. Label the important points. Okay? Hear that? Everybody hear that? Okay. Because I don't want you to lose the point that you are able to get. Alright, let's try our best to get as many points as we are able to. Okay? How many of you want to get an A in this course? Everybody, right? Let's try our best. Okay, so here we have the key points. They are 0, 0, 1, 1, and minus 1, 1. Okay, so and then here label them, and then you see how those points change. And that's why if you don't put the important point, I can't tell how it changed. See, just look at this picture. It looks like it passed through this point, this point, this point. It's so vertical. So I can't tell from this picture how would that point change, right, everybody? So if I cannot see like it's multiplied by a factor of 4, then you won't earn the points of this step. Okay? So please label the important points because then you can tell me how this point changed, right? From here to the 4, then you tell me. And also here, if you don't label the key points, I can't tell from here which point it passed through. Okay, everybody? All right. And yeah, x squared, the parent function, start with 0, 0. Okay. Yeah, and show the key points. Okay. When I say key points, do you understand what are those points? For example, x squared, the key points are 0, 0, 1, 1, and negative 1, 1. X cubed, 0, 0, 1, 1, and minus 1, minus 1. Right? Absolute value, 0, 0, 1, 1, and minus 1, 1. Right? And square roots, 0, 0, 1, 1, and 4, 2. Cube roots, 0, 0, 1, 1, 8, 2, but minus 1, minus 1, minus 8, minus 2. Right? Those are the key points. Okay, because you plot the key points, you can show me how those transformations add on those key points. You can connect those key points smoothly to get a graph. Yes. And then this student, yeah, this is correct refraction, and then but where is the stretch? So missing one picture. Okay, so missing one picture of the stretch. Okay, and here, so this is correct, but this is wrong. Okay, so when you write down your solution, don't write down like something wrong. Okay, so this guy is bounded between is less than or equal to 4. That means it's bounded between 4 and minus 4. So, but yeah, don't write down this less than 0 or greater than equal to 0. So don't write this down. So if you write down something wrong, you get points off, even though you have some correct stuff here. Okay, so be careful. If you figure out something's wrong, gloss it, then I don't grade those parts. Is that okay, everybody? And then here, this is x squared, and this is reflect over the x-axis. Yeah, the minus sign in front of the whole thing reflect over the x-axis, which is right here. And then, yeah, shift up 2 units. Okay, shift up 2 units, plus 2. The negative 4 will tell us reflection over the x-axis and stretch by a factor of 4. Okay, the shift up or down is look at this number. Okay, so do more exercise. And then here also, yes, what is the key points? Right. So you plot the key points so I know that how it changed. Okay? Because yeah, here this point multiplied by 4, then it's not -2, it should be -4. Okay. And then here missing the square. And where is the reflection over the x-axis? There's a minus sign here. Okay, so miss one step. And less than equal brackets. Don't use parentheses. Parentheses means excluding endpoints. Okay, everybody? All right. Yeah, and this is vertical stretch by a factor of 4. Oh, don't forget to connect your points. So check your work carefully. So after you finish your exam, if you have more time, please check your work. Okay? I would say check at least 3 times if you have more time. Okay? Because I remember when I took my math exams, I checked my exam 5 times, and every time I had a mistake. So, but usually sometimes I make mistakes too. So check our work because you don't want to miss the point that you know how to do it. It's just like, yeah, just like this, not careful enough to make a mistake, you will really regret, right? So check your work again and again. Okay, if you have more time for the exam. Okay, and then here, oh, the end. Label the points. Okay, so please label the points. Here, yeah, the student not quite familiar with the steps. Okay, so look at our class notes and all come to see me. Okay, I'm happy to explain to you. So I don't know who made this mistake, but please try your best to study hard and ask me questions. Yeah, and this problem as well. Okay. Yeah, label the important points. And then he didn't follow the steps. Okay, so yeah, look at the in-class notes and follow the steps, the transformations. And here, brackets, don't use parentheses. And and then here, oh, vertical stretch. See, this point stays here, and then here x value stay the same. The y value multiply by 4 right here. Okay, so and then shift up 2 units. Okay, and that's it. Any questions about the mistakes? Okay, so then now do you feel like better understanding about the quiz problem? Yes. Any questions? All good? Okay. Yeah, so for those of you come in late, look at me. You know your homework, you can look at the homework solution. If you click your homework and then when you click submit, okay? When you click submit, you will get to this page. But don't quit and say yes. You can view detail. Okay, you can view detail and then you can see all the solutions to all the problems. So you can understand those and then you can open a second attempt to continue to do your homework. Sometimes you might have the same type of problems, but only the number change, but the idea are similar. You can like try to work on the new problem. Or sometimes it may generate a new type of problem. But I would say most of the case, you will have the same type of problem, but different numbers. Okay, so yeah, and you can do your homework multiple times until you get 10 points. And there is an option print. Okay, so you can print it and then save as a PDF. So my suggestion is you print all your homework as PDF. Then before the exam, you can study for your homework. Okay, everybody? All right. Okay, so good. That's the quiz and the homework. And do you have any questions of anything, of any problem? Let me see. Did someone attach a new question? Let's see. Oh, okay. All right. Oh, by the way, remember that problem, the complex number problem that the model has questions. So I told them that, and they already fixed that problem. So hopefully, if you open a new attempt, then enter that problem again, it should be fixed now. And for some of you, I already helped you to fix it. So you see your score of that problem is correct now. Okay, let's continue. So last time we talked about how to graph polynomial functions, right? The first step is we factor it, right? If you see a common factor, oh, in this case it's x, and we want the leading coefficient to be positive. So we factor out -1. So then this guy is now positive, right? And because this is a quadratic function, we can factor it. By the way, if you don't know how to factor it, you can use quadratic formula. Okay, after you use quadratic formula. Okay, so remember ax squared plus bx plus c. Okay, if you get your x is -2a, negative b plus or minus b squared minus 4ac over 2a, and this is the root. Okay, you get two roots if the discriminant is positive, right, everybody? Okay, if discriminant is okay, so let's say discriminant is positive, then we get two roots. Then you can rewrite this guy to be equal to a times x minus r1 x minus r2. Okay, because in this problem, your goal is to factor it. If you truly don't know how to factor it, you can use the quadratic formula, and then after you find the roots, you can rewrite this guy by a times x minus the first root, and then times x minus the second root. Is that okay, everybody? And second case, if the discriminant is 0, then it means this guy is 0. So the root is, so this guy is 0, the root is minus b over 2a. Yes? Then you know you can rewrite this guy by a times x minus this root square. It's a complete square. Okay, everybody? So this factor, the multiplicity is 2. Remember, multiplicity is the number, the power of the corresponding factor. Yeah? Okay. And the third one, the discriminant is negative. That means, so if a is positive, that means this whole thing, ax squared plus bx plus c, is always positive. So it won't equal to 0. Okay, everybody? Yes? Now, so this is how we did. We factor it and we find the zeros or the roots, and then we know the x-intercept. The y-intercept is we plug in x is 0. And we plot those points on the xy plane, and then we look at the leading coefficient. The leading coefficient is -1. Then we start with the right lower corner, right? Remember, if the leading coefficient is positive, we start with the right upper corner, okay? And then we look at the multiplicity. So 3 is here. It corresponds to the factor x minus 3. Do you see the multiplicity is 1? So if it's up, we cross it. And then 0 here. So 0 corresponds to x. The multiplicity is also 1. So we cross it. Yeah? And then -1 corresponds to the factor x plus 1. The multiplicity is also 1. We cross it. So if multiplicity is up, we cross it. If the multiplicity is even, we bounce off. Okay? Any questions about this problem? We did it last time. And then before we do example 5 and 6, let's flip to the next page. Okay, let's flip to the next page first. Okay, because next page we talk about multiplicity. Yes, so let's just write down what we discussed before. So multiplicity is the power of the corresponding factor, right? So C is the root of multiplicity, K. And for example, the 5 has multiplicity what? 3. Yeah? And the 1 has multiplicity 4. Exactly. Is the power of the corresponding factor. Okay, everybody? Yeah, if we have an odd multiplicity, we pass through, we cross the x-axis. If we have an even multiplicity, we bounce off, okay? And look at this example. We find the roots. Let's list the roots. What are the roots? Let's look at from the right side to the left side. What is the roots? 2. Yes. And what do you think the multiplicity? Odd or even? Yes, because we cross it. So it's odd. What is the next root? 0. And the multiplicity is even because we bounce off. Right, everybody? How about the next root? -1. And then the multiplicity is even because we bounce off. Is that okay, everybody? Yes. So we look at the roots and the multiplicity, and then it just depends on whether it's even or odd, and we know the picture. Okay? We know it's positive or it bounces off. Okay, good. Now we come back. We come back to example 5. All right. So let's see. The first step we want to factor it, but it's already factored. You see, everybody? It's already factored. Then so we can write down what's the root. Okay, so to find the root, we set each factor equal to 0. By the way, we set each factor, including containing the x. Let's do. Do you see this 2? Okay, 2 does not have an x. So 2 cannot be 0. So you don't need to set 2 equal to 0. Sometimes some students will get confused and say, oh, x equals to 2. No, x is not equal to 2. Okay? This 2 is kind of like the part of the leading coefficients. It's a constant multiple. Okay? So we set each factor containing the x to be 0. And solve for x. Here, what do we get? 3. And here we get -1. So the x-intercepts are what? 3, 0. Remember the x-intercept, they are points. The y-coordinate is 0. Yes, everybody? X-intercept, they are points, such that the y-coordinate is 0. Okay. And the other point is -1, 0. Okay, to find the y-intercept, we plug in f of 0. Okay, f of 0, that means we plug in x is 0. So we have the 2. Then do you see this is 0 minus 3 squared? So it is -3 squared. And then 0 plus 1, so it's 1 squared. Yeah, so -3 squared is 9, right? What's 2 times 9? 18. So the y-intercept is a point. The x-coordinate is 0. So 0, 18. Is that okay, everybody? Awesome. And now let's look at the leading coefficient. Okay, so leading. Okay, let me save it first. Okay. Leading coefficients. That is, you look at the product of the coefficient of the leading term. So it will be 2 times. Do you see this is like 1 times x? Right? So the coefficient of x in this factor is 1. So the leading coefficient is 2 times 1 squared times the coefficient of x is also 1, right? So 1 squared. So to find the y-intercept and the leading coefficient, they're kind of similar. But to find the y-intercept, you are looking at the constant, right? But when you find the leading coefficient, you are looking at the linear term. Is that okay, everybody? The leading term, leading coefficient of each term. Okay. So that's why we get the leading coefficient is 2, which is positive. So if it's positive, we start with the right upper or lower? Upper corner. Okay, we're ready to draw it. So x-intercept 3, 0. And -1, 0. By the way, when you draw the picture, you don't need to put a lot of bar and count it. You don't need to. You just put a dot there and say this is 3. That's why I label it, but don't put so many bar there. For example, your y-intercept 0, 18. Do you want to really count to 18? No. Maybe your exam problem, I will ask you 9,532 for the y-intercept. Do you want to count 9,000? No way. So just put a bar there and say that is 9,000 or something. Okay? So 18. We just put a bar here and say this is 18. So it passed through the x-intercept 3, 0, -1, 0, y-intercept 0, 18. Is that clear, everybody? So instead of putting the bar, label it. Okay? And then we start with the right upper corner. So, okay. And 3 corresponds to this. What do we do? Cross or bounce up? Bounce up. So which means we go like this. Oh, do you see? We connect the y-intercepts. And then we get to this point again. What do we do? Bounce up. It's also even. So we bounce up and get this. So this is the picture. So far, so good, everybody? Yes. Awesome. Okay. Now let's do more exercise. Okay. Look at this problem. We want to sketch the graph. So the first thing you do is to factor it. Okay? Do you find a common factor here? Can we find a common factor? No, right? The constant does not have an x. So no common factor. If we have a trinomial, you're trying to factor it. But if you see 4 terms, okay, if you see 4 terms, you can group 2 of them together and then the other 2 together to see whether you have common factor. So if you have 4 terms, group the first 2 together. Okay, so oops. So group the first 2 together. So x cubed minus 2x squared. And then group the last 2 together. But do you see when you group the last 2, the plus 8 become minus 8? Because now it's inside the parentheses. Right, everybody? Okay, factor them. What's the common factor? The first 2 terms. X squared. Oh, what's left? X minus 2. And then the last 2 terms, what's the common factor? 4. What's left? X minus 2. So far, so good, everybody? Ooh, do you see? This term has the factor x minus 2. This term also has the factor x minus 2. So now x minus 2 is the common factor of those two terms. Can you see that, everybody? Yes? Oh, so x minus 2 is a common factor. What's left? Yeah, x squared minus 4. So far, so good, everybody? Okay. Can we factor further? Yes. Can we factor x squared minus 4? Do you remember a squared minus b squared is a plus c times a minus b? So what is x squared minus 4? X plus 2 and x minus 2. Yes. So we have x plus 2 and x minus 2. Oh, do you see we have two copies of x minus 2? So we should combine them together. So we have x plus 2 and x minus 2 squared. We need to combine them because what's the multiplicity? 2. It's not 1. It makes a big difference, right? Okay, so x-intercept. Solve for x. X squared, we get what? -2 and 2. So the x-intercept, they are points. So they are -2, 0, and 2, 0. Good. Okay, now y-intercept. If we plug in f of 0, what do we get? 8. See, when you plug in f of 0, you look at this formula. You don't want to look at this formula, right? Yes? You look at this formula. This is much easier, right? So all the x term is gone, so we get 8. And what is the y-intercept? It's a point. 0, 8. Good. Okay, what is the leading coefficient? 1. Is that okay, everybody? The leading coefficient is the coefficient of the leading term. The leading term is the highest power term, which is x cubed. So the coefficient is 1. Oh, do you see? This is positive. So we start with what? Yeah, upper top right. Oh, yeah. Okay, corner. Okay, and then we're ready. So we have the x-intercept, -2 and 2. So we plot the points there. 0, 8, plot the point there. Okay, everybody? You see, you don't need to put so many bars there. No, the picture is clean. Okay? So, and then we start with the right upper corner. Okay, so start with that. Okay, at 2, what do we do? Bounce. See, the multiplicity is 2, so we bounce. That's why we can go through the 8. Do you see that? If you get caught, you see, no, there's no way I can connect that point. And then you know, something's wrong. Yes, everybody? Okay, how about here? Cross, right. Cross it. Okay. So this is what the picture looks like. So far, so good, everybody? Awesome. Okay, let's continue. All right. Okay, intercepts and turning points of polynomial functions. A turning point of a graph is a point at which the graph changes directions from increasing to decreasing or from decreasing to increasing. The y-intercept is the point at which the function has an input value of 0. x-intercepts are the points at which the output value is 0. Yeah, x-intercepts, the y-coordinate is 0, y-intercept, the x-coordinate is 0. Turning points, peaks and valleys. So facts, every polynomial of degree n has at most n minus 1 turning points. So far so good? You can think of the example. Degree 2, let's say degree 2. X squared. Do you see we only have one turning point? Yeah, so the number of turning points is the degree subtract 1. Okay, so degree 2, you have one turning point. Degree 3, you have at most 2 turning points. Right. That's if the polynomial has n turning points, then the degree is at least n plus 1. Okay, the degree is the number of turning points plus 1. Right? Okay, example 7. What is the least degree the polynomial shown below could have? How many turning points? 1, 2, 3. Yes, everybody? We have 3 turning points. Okay? And we know the degree is at least 1 plus that. So the degree is at least what? 4. Okay. Degree is at least 4. And yeah, that's it. Very easy, right? Mm-hmm. Okay. Yes. And then how about, oh, okay. Now it's your turn. Sketch the following polynomial. Find the x-intercept, the y-intercept, the leading coefficients. Yeah, your leading coefficient and your y-intercept could be a very big number. That's okay. We just get to. Yeah, the y-intercept can use. Yes. And then to get the -7. Yeah, your y-intercept is big. That's normal. Okay. So in the exam, you will have a problem like this one. Yes. So what's the first step? Yeah, set factors equal to 0. So we have 5x plus 4 is 0. X minus 11 is 0. 2x minus 5 is 0. So what is x? Negative 4/5. And how about here? 11 here. 5 divided by 2. Good. So our x-intercepts are negative 4/5, 0. Right? And 11, 0. And the 5/2, 0. Do you get that, everybody? So these are the zero, or you can say the roots. So they are the x-intercept of the function, right? Okay, next to find the y-intercept, we plug in x is 0. You see when we plug in x is 0, -7. You see the x is 0? So you multiply by 4 cubed. Yeah? And times x is 0. Oh, so it's -11 squared, right? X is 0, -5 to the 4th. Is that okay, everybody? And do you know negative squared become positive? Yes. So our answer is negative 7 times 4 cubed times 11 squared times 5 to the 4. Big number. So in your exam, you can use your calculator. So what do you get? Oh, like that? Oh, 0. Yes. Okay. So our y-intercept is 0, comma, this crazy number. Is that okay, everybody? Yes. And then leading coefficients. Okay. The leading coefficients. By the way, my leading coefficient for the solution posted on the website is wrong. Okay. What I did, I just look at the -7. That's not enough because for each factor, you need to look at the leading coefficient of each factor, right? So that's why we have what? 5 cubed, and then 1 square, and then 2 to the 4. Okay, but here, the good thing is you only care whether it's positive or negative. You don't care what the number is. Okay? So as long as we know it's a negative number, then it's good. You don't need to plug into your calculator. Is that clear, everybody? We know we're gonna start with the lower right. Yeah. Okay, we're ready. So real number line. Don't put so many bar there. You look at the x-intercept, -4/5, okay? And 11 is so big, so you can put the 11 here. And 5/2, you can put it here. And by the way, when you plot those points, it's okay that the scale are not quite right, as long as you label it. Okay, everybody? So you don't have to, put 1, 2, 3, this is 2.5, 11. Yeah, it's okay, right, everybody? Of course, if you want to make it better, then maybe we should write this closer to that, because -4/5 is less than 1. The length is less than 1. This is like 2.5, so longer distance, right? Okay, but the y is so small, so -33, and 4 zeros. Okay? Now we start with the right lower corner. So, and then what happened? We bounce across. Bounce. And then bounce. See, we bounce. We also cross the y-intercept. Hey. This is bad. Okay? Because it looks like I crossed it another time. So erase that and draw again. So draw again. Okay. So where's my eraser button? Here. Okay, so draw again. And then what? Cross. Yes, so this is what the picture looks like. So you will have a problem like this in the exam. Okay, you ready? All right. Oh, we still have 10 minutes. How about let's look at the next worksheet. I know you might not have the next worksheet, okay, but we can at least talk about the theory of it. So 3.4. Solving other types of inequalities. Okay, so graphical approach to solve inequality. So here we already have the graph. You know this is a line, right? And how many points can fix a line? 2, right? 6. Do you see 4 is the y-intercept? Okay, and then the slope is -2. So you know slope is rise over run. So you can think of, yeah, -2/1. So that's why we go to the right 1 unit and we go down 2 units. Yeah, we go to the right 1 unit and we go down 2 units. And then you connect those 2 points, you can draw the line. Okay, everybody? And then for the inequality, 4 minus 2x greater than 0 is like y equals 4 minus 2x is greater than 0. You know, y is bigger. Bigger means it's above the line or below the line. Y is bigger. Above. Yes, the y more positive is up there. Down there is more negative. How about your x? X more positive is on the right hand side. The left hand side is negative. So how do you draw it? So usually you draw it, let's see. Okay. So yeah, this guy is bigger than 0. Then we have this picture. Okay. 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 So y is bigger than 0. So the y value bigger than 0. Okay. So y value bigger than 0. So y is bigger than 0. Here. You're talking about this curve, and the y is bigger than 0. You know the y, this is the y values, okay, bigger than 0. Here, this is the x-intercept, so the y at this point is 0. But bigger than 0, that means we need to put a open circle here, right? Do you agree, everybody? We put open circle here, and these p's, the y is bigger than 0. So, therefore, if you look at the x, your x is what? Look at this piece. Less than 2. Do you see from the picture? X is less than 2. Okay, so x is less than 2. Therefore, our interval notation, negative infinity to 2, open. So this is how to look at the graph and figure out the x values. Of course, you can solve the inequality, right? So like usual, how do we solve the inequality? We add 2x on both sides, right? And then what? Divided by 2. When we divide it by a number, a positive number, it won't change the inequality, right? So you get 2 bigger than x. It's the same thing as x less than 2. Do you see we have the same results? Yes, everybody? Mm-hmm. Okay, and how about this? Okay, we're given the graph, and we want to solve the following inequalities. This guy greater than 0. So you look at the y value. See the y value greater than 0. Then you get this piece and this piece. Yes, everybody? So we have y value greater than 0. So we have this piece. Do we include the x-intercept? No. Okay. Now can you tell me what the x values is? Less than negative 2 or x is greater than, is it 3? Yes, right? Okay, so interval notation, minus infinity to negative 2, brackets or parentheses? Parentheses, or then you put union, remember union, this is or, then 3 to infinity. Okay, how about part B? Less than or equal? Well, less than, the y value less than is below the x-axis, right? Or equal means intercept the x-axis, right? So in this case, you put closed circle and closed circle here. And can you tell me what the x values is? Between, yes. So we put bracket or parentheses. Bracket, negative 2 and 3, bracket. So far, so good, everybody? Okay, very good. Now you do this one. Here you're given the picture, and you need to figure out the following. Try to write down the answer. Okay, so please work on this problem at home, and then on Friday, we'll go over the solution. Have a nice day.